Alright, so today we're going to learn how to factor these polynomials using a greatest common factor. And it's really just using kind of a bunch of tools that we've already done and kind of just undoing what we just did in the last chapter when we distributed. Alright, so to start this problem, what you want to do is you want to look at all the numbers first. Alright, so I got a 2, I got a 6, and I got a 12 here. And I want to ask myself, what is the biggest number that can go into all those? And I say, well, 2, 6, and 12 are all even. I know that the number 2 will go into all of them. 2 is the GCF of 2, 6, and 12. Then you want to go back and you want to look at all the variables. I got an x cubed, an x squared, and an x. Right? And the greatest common factor of all of your variables will always be the one with the smallest power. So I got x cubed, x squared, and just plain old x. Well, x is the one that is the smallest power of all those. So that's going to be my GCF for the variable. So 2x together is going to be the GCF of the entire polynomial we have here. Now, we got to fill in our parentheses in such a way that if we were to distribute 2x to 3 different terms here, that I would come out with this answer. Alright, so to pull this off, what we need to do now is we need to ask ourselves, alright, so I got 2x. 2x times what would be 2x cubed? Well, I've already got a 2 and a 2 to match up, so I don't need to multiply my coefficient here. But to turn x into x cubed, I would then have to times it by x squared. Then we move on to our next term. I got 6x squared here. So to get 2x to turn into 6x squared, I would have to times the 2 by 3 to make it be 6, and I have to times the x by x to make it x squared. Because I know that if I take 2x times 3x, I want to get 6x squared. And then you just move on to your last term here. To make 2x turn into 12x, I would just have to times the 2 by 6, and I already have an x right here, and all I need is an x, so that's just going to be the end of my parentheses here. And you can go ahead and check your work. If you went ahead and distributed 2x times x squared, you would get 2x cubed. If you did 2x times 3x, you would get 6x squared. If you did 2x times negative 6, you would get negative 12x. So that's how you know that you did the problem right, and that makes you very happy. Alright, so go ahead and hit pause and try this problem out on your own here. Okay, now I'm assuming that you hit pause. So when we look for our GCF, I look at the 4, the 6, and the 8, and the biggest number that can go into all 3 of those is a 2. And then I got to go and look at all my x's. I got x to the 5th, x cubed, and x squared. So they all have an x, so I take out the lowest power of x, which is x squared. Then I got to fill in my parentheses so that if I were to distribute, I would get back to my same answer. So I do 2 times what will give me 4, and I come up with 2. And then x squared times what would be x to the 5th. Well, I got 2 of them. I need 5 in total, so that means I need 3 more, so x cubed. And then I do 2 times what is 6, and that would be 3. And then I got to do x squared times what is x cubed. I got 2. I need 3, so all I need is just 1 more. And then for our last term, 2 times 4 is 8, so I do my 4. And then I have an x squared, and all I need is an x squared, so this is actually the end of my parentheses. I will not put anything here, because I've already got x squared. 2x squared times 4 is 8x squared. So that's your answer. Here's another example. So when I find my GCF, look at all your numbers. 18, 6, and 9. The biggest number is 3 that goes into all of them. 6 can go into 6 and 18, but 6 won't go into 9, so I can't use it. So the only thing that I can pull out is a 3. And then I look at all of my x's. I got an x squared, I got an x, and then I got something that doesn't have an x. So because this 9 doesn't have an x, I cannot pull an x out in my GCF. So my GCF is simply 3. And now I need to fill in my parentheses so that if I were to distribute, I would get back to my answer. So I got to do 3 times what is 18, and that would be 6. And I don't have any kind of x here at all, and I need x squared, so I need to make that 6x squared. And then I do 3 times what will give me 6, and that of course is 2. And I also need to have that x, so I need to fill it in with an x. And then my last one is finally 3 times what will give me 9, and that is just simply 3. So now try this example out on your own. Okay, so now you should be off of pause and trying this and watching how this happens. So we got 6x squared plus 9x plus 3. As I look at all the numbers, 6 and 9 and 3, 3 is the biggest number that goes into all of them. And then when I look at their x's, this 3 doesn't have an x, so I can't pull an x out for my GCF. So 3 is my GCF. Then I got to fill in my parentheses. So 3 times what is 6? That, of course, is 2. And then I need to throw in that x squared. And then I got to do 3 times what is 9, and that is going to be 3, and I got to throw in the x. And now this one is kind of weird. 3 times what is 3? A lot of times people get kind of stuck on this one. When your GCF is actually one of your terms, then you got to fill it in with a 1. Because if I were to distribute 3 times 1, I would obviously get 3. That's just kind of a weird one when your GCF is actually one of your terms. Alright, here's another one. As we find our GCF, I got a 7, a 2, and a 3. And there's actually nothing that will go into all of those except for 1. And you don't ever need to pull a 1 out of a GCF. So 7, 2, and 3, nothing goes into all of those. But that doesn't mean there's not a GCF, because we now need to look at our x's. I got an x to the 5th, x cubed, and x squared, so they all have an x, so I take out the lowest power, which is obviously 2. So my GCF is simply x squared. And then I got to fill in my parentheses so that if I were to distribute, I'd get back. So I got x squared. To get back to 7x to the 5th, remember there's really an imaginary 1 with this x squared. So 1 times what is 7? That's just 7. And then I got to find out x squared times what is x to the 5th. Well, I got 2. I need 5. So that means I need 3 more of them. So 7x cubed. Then to fill in my next term, to get x squared into 2x cubed, I need to multiply it by 2. And to get x squared into x cubed, I need 1 more x. So I just put x. Then for my last part, to get x squared into 3x squared, I need that 3. And I already have x squared, and that's all I need is x squared, so that's just it. So go ahead and hit pause and try this one out on your own. Okay, so I'm assuming that you hit pause. So now as we look at this, 5, 3, and 2 have nothing in common. 1 is the biggest number that can go into all 3 of those. So that means that I can't pull out a coefficient. But if I look at their x's, x to the 6th, x to the 4th, and x cubed, they all have an x, so I pull out the lowest power of it. So I want to factor out an x cubed. And then I got to fill in my parentheses. So to get x cubed into 5x to the 6th, I need to have that 5, and I got 3 x's. I need 6 in total, so I need another x cubed. Then to get x cubed into 3x to the 4th, I'm going to need that 3. Because again, remember, we're multiplying an imaginary 1 here. So 1 times 5 was how we got to 5, and 1 times 3 was how we got to this 3. But now to get x cubed into x to the 4th, I want to need another x, because that's really to the first power. We just don't have to write it. And then for our last term, to get x cubed into 2x cubed, all I need to do is multiply by 2, because the x cubes already match up. So just plus 2, and you're all done.